Paper 1, question 7 onwards. Find the equation of the straight line shown, write it in the form y equals mx plus c. C is the intercept, so I can say straight away that C is the point 4. The gradient of this line, which is represented by m, is how far up do I go for every one square across. So if I move 1 unit across, I have had to drop 2 units down, which gives me the gradient of 2. Because this line is sloping this direction, the gradient must be minus 2. Now going back to the form y equals mx plus c, I get minus 2x plus 4, and that is the equation of my line. Write down the equation of a straight line that is parallel to y equals 5x. For two lines to be parallel, that means the gradient must be the same, because if the gradient is the same of two lines, they will never touch. Therefore, as long as I have the gradient 5, which is the value m in front of the x, I can put plus or minus any number on the end, and those two lines will be parallel. If I want to find the midpoint of two points, I need to work out what is halfway between the x values. So halfway between 2. So between 2 and 6, we have the middle point is 4, and then between minus 7 and 13, there are 20 numbers. So we half that, which is 10, and we go 10 further on from minus 7, which will give us 3. Question number 8, simultaneous equations. We need to eliminate either the x or y value from one of the equations by making the coefficient in front the same. I'm going to times the first equation by 4, and I'm going to times the second equation by 3. That will give me 12x plus 16y equals 76, and I will get 12x plus 15y equals 69. When I subtract these equations now, I will get rid of the x's, and I will be left with y equals 76 minus 69, which is 7. To find the corresponding x value, I will substitute that back into my original equation. 3x plus 4 times 7 equals 19. 3x plus 28 equals 19, so 3x equals 19 minus 28. 3x will equal minus 9, so x will equal minus 3. So my final solution is when x equals minus 3, y equals 7. Question number 9. Solving the following equation. I need to find a number with which 3, 6 and 9 all go into. The smallest number that can be is 18. I'm therefore going to times each part by 18. Before I expand the bracket, I am going to cancel the fractions down. So I'm going to have 18 times 2 all divided by 9. Now 18 divided by 6 leaves me with 3. 18 divided by 3 gives me 6, and 18 divided by 9 gives me 2. I'm now left with, by expanding the brackets, 3x plus 9 plus 12x minus, because this is minus 5 times 6, minus 30 equals 4. 3x plus 12x is 15x. 9 minus 30 is minus 21 is equal to 4. So 15x is equal to 25, taking this over and adding it. So x is equal to 25 divided by 15, which can be left as that, or you can simplify it slightly by dividing by 5 to 5 over 3. Question number 9. Write these numbers in standard form. Standard form means we have to have a number smaller than 10 at the start, so I have to put a decimal point in between there. Times 10 is always there, and I'm going to count 1, 2, 3 places to give me to the power of 3. Works the same with small numbers. I have to have something bigger than 0 and smaller than 10. So 4, and then I'm going to move 1, 2, 3 back, but this time it will be a negative power. If I want to do a division sum, I divide the numbers, so 5.6 divided by 2, which is 2.8, and then with the powers I subtract, so that becomes 6 minus minus 3, which will turn into a plus, so I get the power 9. For adding and subtracting in standard form, I need to convert these numbers back to whole numbers. So 8 times 10 to the power of 3 would give me a point there, and I'm going to have to make it 1, 2, 3, which would give me the number 8,000. With 2, I get the number 2,000, so my answer is 6,000, which I can leave as 6,000, or that is the same as 6 times 10 to the power of 3. Cumulative frequency diagrams. less than 20 is 4. Less than 40 will be these 4 plus those 12, which gives me 16 altogether. Less than 60 will be those 4 plus those 12 plus those 34, which is a total of 50. And then less than 80 will be the whole lot, which is 60. When it comes to drawing the cumulative frequency diagram, I need to use that table. So I find that at less than 20, there were 4 people. At less than 40, there were 16 people. At less than 60, there were 50 people. And at less than 80, there were a total of 60 people. Now, with cumulative frequency, I am able to join this up by straight lines or a smooth curve. If you can do a curve, it is slightly more accurate, but they do accept straight lines for cumulative frequency. If I want to find the median, there were 60 people asked, so the median value will be 30. So I'm going to draw a line across at 30, and I'm going to draw down from 30, and I'm going to read off that value 45, 46, 47, so the median is 47. To do the interquartile range, I need to do 3/4 of the way up the data, take away a quarter. 3/4 of the way will be at 45, and 1/4 of the way will be at 15. So again, I draw lines across to my cumulative frequency diagram, and from each of those I drop lines down, and then I read the values and subtract them. So this is the value 57, and this is the value 35, 36, 37, 38, and then I'm going to subtract them, which gives me an interquartile range of 19. The nth term patterns question. This was one of the toughest questions on the paper. If I want to do a 20 by 20 pattern, I'm going to look at a 2 by 2 pattern for reference. In a 2 by 2 pattern, there are 4 tiles, which is found by doing 2 times 2. Half of them are white and half of them are black. In a 20 by 20 pattern, then, there will be 400 tiles in total, and there will be 200 of each, because from the 2 by 2 case, we can see that there's an even split. For the 15 by 15 tile pattern, I'm going to look at a 3 by 3 pattern to give me reference. In a 3 by 3, I still multiply the 3 by 3 to find there are 9 altogether, but there is one more white tile than there is black tile. So I'm going to do 15 times 15, which is 225. If I half that number, I get 112.5. Now, to make sure there is one more white tile, I'm going to have 113 of the white and only 112 of the black. To do the nth term for these questions, I'm going to make reference to the questions beforehand. So if there is x tiles by x, where x is an even number, find the nth term. Now that follows this same scenario we just did here. So what we did was we multiplied the numbers together. So in our case, that would be x times x. That told us how many there were in the whole pattern. And then we halved it to find each black and white. So we're going to half it up here. So we're going to get x squared divided by 2, which will tell us how many black tiles there were and also how many white tiles there were. So I'm just using exactly what we did with the scenario here to work out the nth term. That works the same for an odd number. With the odd number, we started in the same way. We multiplied them together and halved them. But then to find the number of white tiles or the black tiles, we had to add or take away 0.5. So the number of black tiles was y squared divided by 2, and we subtracted 0.5. And for white tiles, we added 0.5 to get the correct answers. Question number 10. To find a histogram and find frequency densities using the information we've got. To find frequency density, we do frequency divided by the group width. So 8 divided by 20 is 0.4. 16 divided by 10 is 1.6. 20 divided by 10 is 2. 42 divided by 10, 4.2. 24 divided by 10, 2.4, and just be careful with the last one because the group is 20, so it's 4 divided by 20. Well, 4 divided by 10 would be 0.4, so if we half that, then we get 0.2. To draw the frequency, the histogram, we plot the group width against the frequency density. So between 130 and 150, we're going to go up to 0.4. So between 130 and 150, we're going to go up to 0.4, and we represent it in the same way we would do bar chart. So we go up to 0.4 between 130 and 150. For this one, 150 to 160 is up to 1.6. So between 150 and 160, we're going up to 1.6, and again, we're representing it by a bar. For 160 to 170, we're going up to 2. So from 160 to 170, the frequency density was 2. For 170 to 180, it was 4.2. So we're going to draw a bar again here. Just be careful to make sure you are following the correct group widths. 180 to 190 was 2.4. So 2.4 is by here, and that's between 180 and 190. Again, that's represented by a bar. And then between 190 and 210, it was just 0.2. So that will be across there, which takes us right to the end of the graph. And that is the completed histogram. If I want to calculate an estimate for the number of people in the group whose heights are at least 162, I can use my table of data to work that out. If they have to be at least 162, everybody in this group will be, so all 42 of them are. Everybody in this group and everybody in that group also are. So they are definitely, and that gives me 66 plus 4, which is 70. Now the problem comes with in this group of 160 to 170. Some of them will be and some of them won't be. We don't know for exactly how many. What we're going to say is that 162 is a fifth of the way into this group. So we're going to ignore a fifth of this group and include the rest of them. So 1/5 of 20 equals 4. So we're going to say that 4 of them were between 160 and 162, which leaves the other 16 to be bigger than 162. So we're going to add those on here, and we're going to get a grand total of 86 people were at least 162 centimeters tall.